No job. I don't want to hurt you.
Okay, so if you look at example 1, we're going to start with what we did yesterday. So if you look at example 1 and it says y equals 4x to the 4th plus 6x cubed minus x. Without the graphing calculator, I should be able to tell x to the 4th and it's positive. So my end behavior is up, up. Identify the degree and classify the polynomial by the degree. The degree is 4, and what was the name? It's quartic. Classify the polynomial by the number of terms. How many terms does it have? 3. So what do we call it? Trinomial. All right, so now it says find the turning points. And here's where I'm going to grab my calculator and pull it up here. So if you're using the website desmos.com or the graphing calculator, whichever way you want to do it, I'm going to add a new graph here. So here we go. You look up where it says example 1, and I'm going to put 4x to the 4th plus 6x cubed. Use the little caret button here. Oops. Oh, yeah, sorry. 4x to the 4th. I forgot to bring it back down. Plus 6x cubed. Bring it down. Minus x. Now, if you don't see this window, you have the option to like zoom it and change it. So if you press, so whether you're doing desmos.com, so you should be able to just type it in with the graph, then, okay, a turning point is where you have a hill or a valley. So looking at this, how many turning points do you see? 3, right? I see one valley, a hill, and another valley. So I've got 3 of them. So what we're going to do is we're going to find them, okay? We're going to find the turning points. If you're on desmos.com, I think you can just arrow right on it. For those of you that have a graphing calculator, follow me. You're going to press menu. Okay, press the menu button. Number 6 is analyze. Okay, number 6 after menu is analyze. And we're going to go find the minimum and the maximum. So let's do the minimum first. And do you see you can use your little mouse pad in the center? And you're going to move it around until you get that dashed line to the left and tap it. And then move it to the right and tap it. So now you should be seeing something along the lines of negative 1.07 and negative 1.4. On desmos.com, are you getting something close to that?
Yeah.
Okay, awesome.
You move it to the right and then...
and you tap the little mouse pad and then move it to the other side of it up to that one valley, or what we call the minimum. So now I'm going to do it again. So I press menu, analyze, and now I'm going to go get the hill. So that's the one in the middle is the hill. So I tap a little to the left and a little to the right. On your papers, you're going to have negative 0.27 and 0.17. I'm rounding 2 decimals. And then I'm going to go get the third one. Menu, number 6 is analyze, and that other one is a minimum. So you got to get kind of close to it. And I'm getting negative 0.22, or no, positive 0.22, and negative 0.15. All right, let me toggle back here to show you that stuff, okay? So it says find the turning points. So I said 0.22, comma, negative 0.15, negative 0.27, comma, 0.17, and negative 1.07, comma, negative 1.04. Anybody need help with the buttons on the calculator or on your laptop if you're doing Desmos? Yeah.
No, I don't have a thing. I just have a question.
Sure. What's your question?
I got some, like they aren't like the exact same as your numbers.
Yeah. Are they close? Real close?
Okay.
like 0.21, 0.23? Is it like that close?
Huh?
Yeah, that's fine.
How do you get the third one again? Like
I
you
just
get-
repeated the same process. I pressed menu, and that third one was a minimum. So I did analyze, and then did minimum, and I repeated the process. Okay, now I'm going to show you how you get the x-intercepts on the graph. So I'm going to go back to the graphing calculator. And I'm going to change my window. So if you press menu, this is for the graphing calculator, and I think you can do this on Desmos. You'll have to look on the tools or settings. And I'm going to change the window settings. And I'm going to click zoom in. And you just move it to the center. And do you see that? I can make it get a little bit zoomed in. So now, if I want to find, okay, so I'm done with that. If I want to find the x-intercepts, those are the zeros. So what you're going to do, for those of you with a graphing calculator, I want to find the x-intercepts, which, if you remember, those are the zeros. So I press menu, number 6, zeros, and then you move it a little to the left, tap, a little to the right, tap. And that's negative 1.37. On Desmos, I think you can just like hover on that and it should be pretty close. Let me repeat it, okay? I'll repeat it. Here we go. So you press menu, number 6 says analyze, and then the first option is 0. Number 1 says the word 0. So let's do it again. So I want this one here, and I go left and right. And that looks like negative 0.5. Let me try and move, see if I can get rid of some of this. Oh, yay. Okay. There we go. Okay. Did everybody get the negative 1.37? Because I want to delete that.
Yeah.
And then I got negative 0.5. And now let me repeat it, okay? So I'm going to do menu, number 6, 0. So now I'm going to get this third one. A little left, a little right. Hey, that's at 0, 0. Okay, that one's at 0, 0. And let's go get the last one. Menu, analyze, the 0. So I'm going to go a little to the left and a little to the right. And I'm getting 0.366. So now, let me show you. And I'll put all these up here, okay? Don't worry. So now my x-intercepts were 0, 0. I had negative 1.37, negative 0.50, and I'm going to round 2 decimals. So now watch this. I know my end behavior. Okay, I know my end behavior. I know this is going up, up. And if I find the turning points, the x and y intercepts, I'm going to estimate them on my graph. All right, so here we go. So I have 0, 0, negative 1.37, so that's not quite to 1.5 on the left, negative 0.5, yikes. Okay, you know what, I don't like this at all. Do you see how that's so teeny tiny on here? Like that's going to be really, really hard for me to get this in. So instead of making my ticks 1, could we make them go by 1/2 instead? Yeah. Then wouldn't that give me a little bit more room? Okay. Unfortunately, when I erase this, it's going to erase everything on here. So do you guys have what I have before I hit my eraser? Or, you know what, do you see how teeny tiny? We could make our ticks be 0.25. Let's do that instead.
Let's do it. Oh, no.
Whoa.
It doesn't want you to do it.
It doesn't want me to do that. Okay.
Oh, what's going on?
I do not know. Whoa.
Is that geometry?
Be quiet.
That's pre-calc. Okay, so here we go. Everybody, I'm going to erase. Oh, it didn't. Yay. Okay. All right, so I'm going to go 1, 2, 3, 4 and call that negative 1. 1, 2, 3, 4, and I'm going to call that 1. Yeah, that'll work a lot better because it was too scrunched. And I know for some of you, like when you got 18 in your table for your y and you said, I can't fit that. Sometimes you have to change your scale, and it's okay to change the other way. So I'm making them go 0.25. So here we go. Here's 0, 0. So now, negative 1.37 is like here. Here's negative 0.5, and here's 0.37. So if you need to put more ticks in here, like this one, 0.25, 0.5, 0.75, okay, that's how I'm getting those. So, and I know it's coming up from the top, it's going to do some wiggles, and it's going to go back up to the top. That's my end behavior. Now, let's get our turning points in here. 0.22 and negative, ooh, let's do the same thing. Let's go down 1 and up 1. Yeah, that'll look good. All right, so here's 0.22 and down 0.15. So I'm just estimating. Negative 0.27 and up 0.17. So I'm estimating. Negative 1.07 and negative 1.04. So it's just a teeny tiny bit under. Okay, I think I got it now. So here we go. I'm coming up from the top because that's my end behavior. This was a turning point. Here's a turning point. And then I need to know the end behavior as it shoots up, up. So when you're going to be asked to graph, and we're going to take our time with the graphing, okay? So we're going to have a quiz not this week, but on Tuesday next week. We'll just really take our time with this because I know that using the graphing calculator in this way is going to be new and different for you. So now, increasing and decreasing. Yesterday I introduced it, but I did not expect you to really master it yet. So today, I'm hoping we'll get a better understanding, but still not complete mastery yet. We'll keep at it. So do you see it's increasing from this valley to this hill, right? So this is negative 1.07 to negative 0.27. You use, and I want you to write this down, we use the x values to describe increasing and decreasing. So this is the minimum, where the valley is negative 1.07. The little hill is at negative 0.27, the x values. Then it's going to increase again from here over. Does anybody want to try and tackle how we would say the last increasing interval? Anybody want to try it? What's the x value at this minimum? Okay, it was, no, not 0.37.
Negative 1.37.
No, look at letter D, your turning points. 0.37 is the X-intercept.
Negative 1.07?
No, this is negative 0.27. This is negative 1.07. This is 0.22, right? So it's going to go 0.22, and then it goes to the right forever. Not that it's going up. It's true, we need it to go up. Then where is it decreasing? It decreases from negative infinity to negative 1.07. So it decreases till it hits this one. And then it decreases between the hill and the valley. That's negative 0.27 to 0.22. So again, I know this is super confusing because increasing means that the graph rises, but we describe the rising part by the x values that are on the x-axis. Okay? All right. Go ahead and flip the page, and we're going to do it again. So I didn't expect you to fully understand yet. So if it's a little foggy, that's okay. That's where you're supposed to be. And it means you're learning something new. So when you're ready, flip the page and use either your laptop or you're going to use your graphing calculator to put this new function in. So we're doing example 2 is y equals negative 2x cubed plus 2x. All right, so I'm going to show you on my graphing calculator. So here's what you do. You go to Document, New Document. I'm not going to save it, and add a graph. So here we go. It's a negative 2x cubed. And I should anticipate before I press graph, okay, and I know you guys think it's silly that I made you dance and do your arms, but here's x cubed. Negative x cubed is going to have an end behavior of up, down. Before I even graph it, I should know that. I'm going to go to Menu, Window, and I'm going to zoom it in because that's too small for me. Ooh, that looks pretty. So I did, for those of you with the graphing calculator, you can press, once you've graphed it, Menu, Window, and do zoom in and tap it a couple times. That looks really pretty. So I'm going to go back here and let's write a few things down. The end behavior was up, down. Identify the degree. The degree is 3, so it's a cubic. It's a binomial because there's 2 terms. Now I'm ready to find the turning points. So last time it was brand new. Now this is our second time to do the turning points. So you go back to your graph. Yeah, Edward? Okay, you press Menu, Window. Do you see the button that says Window? Go to Zoom In. Then you should see a hand and you tap it in the middle and it should like zoom it. Does that make sense? Okay. All right, so here we go. I'm now wanting to find how many turning points do you see on this one? 2. Okay, there's 2 turning points. So you press Menu, number 6, and I'm going to go get the minimum first. Let me repeat that. You press Menu, number 6 is Analyze the Graph, and then I'm going to do minimum. So you just used your little mouse pad on the graphing calculator, tap a little to the left, a little to the right, and I'm getting negative 0.577 and negative 0.77. Let's go get the other one. So you go Menu, Analyze, and that one's a maximum. Tap left and right. Oh, you're right. Okay, so let me go back here and let's fill these in. My turning points are negative 0.58, negative 0.77, positive 0.58, and 0.77. You know what that's telling me is I have some symmetry. Okay, that's kind of cool. Now we need the x and y intercepts. So I'm going to go back to the graph. Okay, I'm going to go back to the graph and I want to do Menu, Analyze, and they're the zeros. Okay, it's really important that you remember x-intercepts are the zeros. I'll bring this screen back, but for now I got to go do my work. So let me pull these off. So here we go. I'm going to press Menu, Analyze, and they're the zeros. I have 3 x-intercepts. Tap left and right. It's at negative 1, 0. Make sure you can do this because on the quiz, you're going to be asked to do this. I'm not quite sure what those of you will have to figure out the lockdown browser so that you aren't on other things to do Desmos. I'll have to figure that out. So Menu, Analyze, zeros. That's at 0, 0. Menu, Analyze. Oh, so it's a lot of symmetry, isn't it? Yeah, there we go. So let me go back here. And let's start filling some of this out. So I have 1, 0. Now, do you understand that 0, 0 is the y-intercept, okay? And negative 1, 0. So now what you're going to do is, let's go by 0.5s, okay? This one I think we can do by 0.5s. So I'm going to go by 0.5. And then 1, and then 0.5 and 1 going up, and let's plot these. So I have 1, 0, 0, 0, negative 1, 0, negative 0.58 and negative 0.77, 0.58 and 0.77. Remember we said it had end behavior like this. So it's coming from positive infinity it turns, and shoots down. So it really is super cool how we're connecting end behavior with the maximums, the minimums, and the x-intercepts. So it all goes together. Letter G says let's do the increasing and decreasing. All right, so now this time, what?
I'm sorry, you're just going really fast.
Oh, sorry. So what's new today is we're figuring out how to do the graphing calculator to find maximum, minimums, and x-intercepts. We've done everything else yesterday, okay? So this is kind of like a second day through, but going a little bit further with the technology. All right, so now let's see about the increasing and decreasing. Let's see if we can't get the hang of this. So do you see it's increasing from the minimum to the maximum? So that minimum, let me look at my paper, the minimum was at negative 0.58 and the maximum is at 0.58. So between the valley and the hill, it's increasing. Then it decreases from negative infinity. Now what I mean by negative infinity is not that it's going to positive infinity, okay? I'm using the x values, okay? It's going left forever, so that goes to, left is x, goes to negative infinity. And then it stops decreasing at the negative 0.58, the x value. Then it decreases at 0.58, and it decreases to the right forever. We're using x values. All right, questions on that?
Wait, shouldn't it be 0.58 to negative infinity? Ms. McInerney?
Yeah, which one?
Or the last one for decreasing, shouldn't it be 0.58 to negative infinity?
No, it goes to positive infinity because the x value is going right. I'm describing it with x values. You're right that the graph is going down to negative infinity. That's true. That means it's decreasing. But the x, this goes 3, 4, 5, 6, 7, 8, 9, 10 to infinity. So, in fact, it does go to positive infinity. All right, last page. What I'd like us to do is we're going to start with George, and then we'll go to Tyra, and we're going to snake around the room, and I want you guys to read one sentence, okay? Starting with the suppose. George, go ahead.
Suppose you're given a set of polynomial function outputs.
None of their inputs are an ordered set of x values in which consecutive x values differ by a constant.
By analyzing differences of consecutive y values, it is possible to determine the least degree polynomial function that could generate the data.
If the first differences are constant, the function is linear.
Okay. If the second differences, but not the first, are constant, the function is quadratic.
If the third differences and the first and second are constant, the function is cubic and so.
All right, and Josh, go ahead and read the first sentence of example 3.
The data of the polynomial function is given in the table below. What is the degree of the polynomial function the greatest that generates this data?
Okay, so this is what we did yesterday. So what we're going to do is we are going to take a series of differences. And when I walked around the room and looked, and on that exit ticket we did, a lot of you weren't writing this. You need to do this. Go ahead and close your laptops. You don't need them anymore for now. So what you're going to do is you're going to find the differences. This is what we did yesterday. So if you have to do a calculator, you're going to take the second y value minus the first y value. So you would take -7 minus -1. I can just tell it goes down 6. This one's going up 4. This one's going up 8. It goes up 6, down 2, down 16. So what you guys just read is if the first differences are constant, then it's linear. Well, these are not constant. A constant means 8, 8, 8, 8, 8, 8, 8, negative 11, negative 11, negative 11. It's the same thing. So now what we're going to do is we're going to take the differences of the differences. So this one's going up 10, this one's up 4, down 2, down 8, down 14. All right, it's not quadratic. Let's do a third difference. So this is down 6, down 6, down 6, down 6. Now, this is not a negative 6 degree polynomial. It's a third degree. It's whatever difference, that's your degree. So we would say it's cubic. All right, I want you to try the next one. Or, you know what, was this the one we had yesterday? I think maybe it is.
Yeah.
Yeah, okay, we're not going to do that fourth one because I think that was on yesterday's notes, okay? So,